Hello everyone and welcome to another Stat385 video. In this video I'm going to go over lab 7. Yes, I'm in the right spot. Okay, so let's see here. So what we're going to try to do in this lab is we're not going to try, we are going to get descriptive information from all of the Illini players who have batted in Major League Baseball and provide some descriptive information on those players and find the best University of Illinois player who has played in the majors according to a select metric that we will use. Okay, so let's just go through it really quick. Okay, best Major League Baseball player who played for the University of Illinois. Write all requested code in an R script named this. The data we will use will be from the Lawman's Baseball Database. This is an excellent resource at our disposal, and we're very grateful. I personally am very grateful that they have made this into an R package to access all of the wonderful data that they have on baseball players. It's great for some of the work that I do. It's great for some of the work that I do in collaboration with Professor David Dalpiaz and with students. It's also just great for a learning audience who is generally interested in statistical programming and data science, just due to all of the analyses and data wrangling and merging of data sets together that you can do and arrive at the end of the day at something that is interesting. And by interesting in this context, I mean that there are some very easy to compute statistics that have been extraordinarily powerful in capturing the value of players, and this has been something that has totally reshaped the understanding of this game of baseball in a way where that wasn't possible without statisticians like yourselves who are so it's very, very interesting stuff. And I think that we can all have an appreciation for it, even if baseball is not the first thing that we're interested in. So, as I've said many times, I am somewhat of a fan of baseball. I do work in baseball, but I'm just very interested in the statistical side of it for the reasons I just said. Okay, so we need to. Okay, so I have R Studio up. Okay, wait. Okay, so I'm in my Stat385 directory. I need a new folder. Okay, so first thing we're going to need to do is obtain the Lawman package. If you don't have it, then you're going to have to get it. Okay, so I have it, so I'll just comment that out. Okay, and I might as well just load in the tidyverse. Okay. All right. Okay. So, right. So note that the version that I have, and I think it's still the version that's available right now, does not have 2023 data. So it's only through the 2022 season. If it has 2023 data, I don't think it's going to change anything for this problem. In fact, there may be more people, but the person who's the best shouldn't change. Okay. Okay. So, right. So our goal is to find the best Major League Baseball player, and we are going to define the best batter, first of all. So baseball, if you're unaware, a very simple description of the game is there's a person who's throwing a ball, that's the pitcher. There's a person who's swinging a bat at the ball, that's the batter. The pitcher represents the defense, and the batter represents the offense. So it's just like a typical sport or game where there's a defensive component and offensive component. This is a really, really rough description of baseball, but it's one that is serviceable. And then in baseball, there are different bases, and they're all encoded by a number. So there's first base, second base, third base, and fourth base, often called home plate. And the idea of the batter is to try to get as many bases as possible. So, one base is worth more than 0, 2 bases is worth more than 1, 3 more than 2, 4 more than 3. So getting all of the bases is the goal here. And so this metric that we're going to use to define best is a balance between getting on base and how many bases you get on average. Loosely that's what it is. We can go to the website and see that there's 2 components: how often you get on base, and then how many bases you get per average. And one thing to note for students who are more mathematically interested students will note that we're adding 2 things that don't have the same denominator. Yeah, it's really silly, and this speaks to 2 things: how much low-hanging fruit there was in baseball for an extremely long time for something that is this fundamentally misguided mathematically to have such value. But that being said, this statistic, even though it has this mathematical deficiency, adding 2 fractions that don't share the same denominator, is extremely valuable in the sense that team level, this statistic, OPS, on base plus slugging, correlates really well with scoring runs, and that's when you get all 4 bases is a run. So it correlates extremely well with scoring runs, and as such corresponds really well with winning games. And I guess it makes sense that it would correlate well with runs, but it correlates well with winning games. So it is still a very useful statistic. Okay, so as you can see, it was popularized in 1984. Baseball, I'm trying to think how far we went back, but anyways, it goes. There's records in this Lawman package dating back to 1871. So 100 years went by before this really simple statistic was created. And what I mean by simple, it's just adding things together and dividing by. It's just like adding and dividing things from a table of data and showing that it correlates a run. So it took 100 years, and it basically revolutionized the game, or the understanding of it. Okay, so what do we want to do? So that's a brief lesson of history, and I hope the main point is there from that lesson is that baseball being a very popular game in our culture and the culture of many countries around the world, and that statistics and data science has had a very, very large impact on the understanding of this very popular game. And I should linger on this one more time and saying that when this movement towards analytics got going, there's a team, the Oakland Athletics, that sort of revolutionized the approach by embracing this stuff against immense pushback, because people in baseball thought that you had to use your eyes to watch the game and that numbers can't really capture the game. So they faced immense pushback from inside, and this a team actually going all out and doing it was a very watershed moment for the victory to come for analytics. And one of the things that I would say is comparable to it is although there isn't much opposition against the power of computers, but if you're familiar with I think it's IBM's Deep Blue machine beating Garry Kasparov in chess to demonstrate the computer power or how powerful its computers could be, this would be very comparable to that kind of thing. Okay, so we need to load in the Lawman package, which I have already done. And we're going to need the tidyverse. We're going to need the following data frames, all from Lawman. So we need people who played in college, people who batters in the MLB. This is information on particular people. And this is schools and coding. So we're gonna have to work with 4 data sets, and our end product is gonna use information from all 4 of these. So this is a very good exercise in data wrangling. Okay. So it says that you need to spend some time exploring them. Pause and do so. You're back. Okay, great. Okay, so then at the end, we want to create a tibble named Illini MLB Batters. Copy the name. Maybe I'll just comment it out for now. And it needs the following elements in order. Okay. So this is a lot of statistical information on players. The ordering of this, a lot of it is given to you for free in the batting package, in the batting table. So actually, let's back up. Let's get all of this stuff and just demonstrate what it looks like. School. So you can. That's annoying. Let's do. Okay, so we can see information encodings of schools. Okay. College playing. Okay, so we have player IDs for college players. You can see that they go back pretty far. This is 1889. And then you can see a school ID. So you can see here a school ID and a name of the school. So you can kind of see how these things can fit together, because there's school ID here, school ID here. Great. That'll be useful. As tibble batting. Okay, let's see batting. So, okay, yeah, this is what I want to show. Games, at-bats, runs, hits, doubles. So you can see games, at-bats, runs, hits, doubles, so forth and so on. So, yeah, they're all in order. This is intentionally done. Okay. And then also note that we have a player ID here, and we have a player ID in college playing, so we can actually get the college players. So if we want all of the college players from Illini, you can kind of see how we're gonna have to get there. And people. Okay. So people, player ID, and then we can see here name first, name last. So they use these player codes, and then there's more description on the players themselves in this people data set. And why do we need this? Oh, because we want name first, name last, and birth year. Okay, so all of these statistics, I think up to here, all come from batting, and then we have to compute these. So there's a lot going on in this question. Okay, so let's see. First of all, let's just get started. Let's look at people. And let's just scan it. Player ID, name first, name last. Okay, so we can see the names of all of the players. Great. And schools. I think the idea is just, the name, the ID is just Illinois for Illinois, which is not with a lowercase I. Yeah, okay. So Illinois, school ID, name full University of Illinois at Urbana-Champaign. That's us. Okay, good. City, Champaign, state, Illinois, country, USA. Okay, so, all right, so we want to do, let's see here. Now let's look at college playing again. Okay, so we have player ID, we have school ID, and we have seasons that they played. Okay, so let's get all of the people who played in Illinois. Okay, so we want filter school ID equals this thing, Illinois. All right, and then, okay, so if we look at this, we can see this person with the coding Ander J01 played for Illinois in 98, 99, and 2000. So multiple times. Okay, so we want to get, I think we can leave it and be fine, but I'm just going to get rid of it. So, okay, if I were to select the column, player ID, that's going to keep this in the form of a tibble, which is not exactly what I want. So I want to actually pull the information out, and I can use this pull function. And so now I'm getting all the player IDs for all the people that are that played for Illinois at any point. But this right now has repeats due to people staying in college for more than 1 year and playing baseball for more than 1 year. So I can use the function unique to just get the unique entries of this vector. So note this Ander J01. Okay, now it's just the unique entries. It's much shorter, right? This goes down to 38, 39, 40, 141 elements. This is 57. Okay, great. So I'm going to call that Illini. These are the people. These are the people in player ID code who have played in the batters who played in Major League Baseball, the people who swing the bat and get the bases, who have played in the majors after playing for University of Illinois. Okay, great. So now, what do I need to do? Okay, first a little bit of background on this data set, which wouldn't be immediately obvious for people who haven't seen it before or don't have much experience with baseball. So I'm gonna just pick an old time player ID equals. Okay, so this player right here, you can see, well, that's very interesting. First, look at SB and CS. This is, so they had records for it. So this is going back to, the 1870s. And they had records for some of these seasons and didn't have them for the other ones. So there's a whole flurry of just NA values throughout these data sets, especially on I don't want to say unimportant categories, but less important categories. And so there's a lot of NAs in the data set, and we are going to want to get rid of them. Okay, so let me see if I can, let me just zoom this out a little bit more. Okay, so you can see, yeah, there's a ton of them. Okay, so actually, let me get rid of, let me go back to the prompt here. So I don't need, we're gonna need, it doesn't have year. We need career values for these statistics. So we're not gonna need year or stint or league ID. So let's get rid of some of those. And we don't need team information. Sorry, doing too much. Minus, let's get rid of stint, team ID, and league ID. Okay, now we can see all of the information. Great, so there's a lot of NAs. Okay, so notice that this is character and everything else is integer. So this is a nice trick here. What I'm gonna do, I'm gonna just, oh wait, that's really ugly. Want that off my screen. Okay, so I'm going to select, or I'm gonna mutate, I'm gonna get rid of all these NA values and I'm gonna replace them with 0. Across G, and I think it goes all the way to, okay, so games, all the way to ground into double play. And I'm going to replace NA, and I'm going to replace with 0. Did I do something wrong? I don't think, oh, that's a warning message. It looks like it did the task though. Okay, so yeah. Okay, and I don't think this causes, I know that like statistically, the idea of replacing values with NAs with zeros is like shorthand that we always do in, that we do sometimes, but like here, this is common practice. So if I go to, this is a website that lists statistics on all sorts of major players. This is actually the player that I have the key on. I've spent a lot of time on knowing what these keys are. And you can see here, this intentional walk. Oh, they don't even have it measured. But ground and double play, 2-2-1-1. They have the measurements here, and then they just have blanks, but it all adds up. They total it to 6. So they are effectively replacing NAs with zeros. Okay, you can see it here with CS again. 10, 16, 16 total. Okay, so this is fine, I guess. Okay, so now we need to do some work from the batting table, not filtering. We want to do this for everybody. Okay. Let's see, how do we want to do this? Okay, first of all, let's just right away restrict attention to the Illini. Okay, so now we have Illini information. We've replaced NAs with zeros. Okay. Now, what we want to do is compute career statistics for the players themselves. And we also need to create some things. Like we have, oh wait, where am I at? We need to create these values. They aren't given to us, but we have formulas for them. Okay, so the way to do this, let's group by player ID. Okay. Let's use that across trick again, across all the numeric values. And we can sum up all, since these are equations, we can get career values for all of these numbers, and then we can compute these things. So let's just get the career values. So let's do that. What was it? Mutate across games to ground into double plays, right? That's all of these columns going into ground into double plays. Okay, awesome. And let's do sum. Okay, so what does this give us? Okay, so this doesn't give us unique values, but it did do the trick. That's fine. Okay. That's fine for now. All right, so group by player ID, cross sum, and then now, okay. So, oh, this isn't copyable, is it? Okay. Well, I have a, okay, so give me 1 second here. I'm back. Okay, so I am now going to create these totals. Some of these are rate statistics, batting average, on base, slugging, OPS, and this is the thing that we want at the end of the day. Okay, so I've copied my equations hopefully correctly. Okay, so all right. And now let's get rid of people who didn't play or didn't bat. Filter PA greater than 0. Okay. And in the prompt, sorry, I keep going the wrong way. In the prompt, it said round any rate statistics to 3 decimal places. So the rate statistics are these right here. I mean, OPS is technically, well, I guess it's a rate statistic. Yeah. It's a weird rate. It's 2 rates added together. Is that a rate? Does that make it a rate statistic? Okay, I'm being really silly at this point. Okay, let's just do the task. It doesn't matter. Is it a rate statistic? Is it not? Conventional wisdom is that it's surrounded by 3 decimal places anyways. That's what the people do, and that's what we're gonna do. Round. This across thing is really nice. And here what I'm doing is I'm passing arguments into round. This is like a dots type thing. And then it understands that this is gonna get passed into round, and I'm going to round all of these with this argument specified. Very, very slick. Okay, oops, no, the whole thing. And if I zoom, you can see, oh, that's all the ones okay, you can see how it's all rounded to 3 decimal points. Very cool. Okay, cool. All right, so now we need, okay, so we have information for all Illinois players. We have career batting information. In particular, we have OPS. Okay, so we need to get, what do we need to get? We need to get name first, name last, birth year. Okay, and that's from people. Geez, I keep going the wrong way on this. Okay, so let's do that. So we are going to left join, excuse me, people. And I'm going to do some manipulation inside of the left join column. So this is going to take it, this would take a tibble. This would take everything from people. Let's look at people again. Has a lot of stuff. Has too much, way too much stuff, including all this stuff that isn't displayed. There's 26 columns. All I want are birth year and name first, name last. So I'm just going to do that. I'm just going to select the things that I want. Player ID, that's going to do the joining. And I want name first, name last, birth year. Okay, and I want to do, wait a minute. Yeah, I want to do the joining by player ID. It will figure this out automatically, but I think it's always good practice to specify it directly. That's what I would recommend. That's what I do. And the reason why I do that is because I have done enough exercises where I've gotten lost, and it's net save time by spending the extra time to type it out. Okay, so if I do this, this is going to take these variables and put them at the end of the thing that I want. So I am going to do another thing. Select, and I'm going to do player ID, name first, name last, birth year, and then that everything trick. Okay. And then everything else would just join in the order that it was, its original order. And just by the way the batting data frame, or tibble in this case, is organized, and the way that I computed these statistics, it'll all be in order. Okay, so this is, I know that this seems like this is a really strange and tedious and gross ordering, but it's just natural to how the columns are organized in the existing data frame. So it looks like really tedious and gross, but it isn't. Okay, so I got everything I want. And I want to do, you know what? This is going to really bother me with these duplicates. Duplicated. What's the command? Keep unique rows, tidyverse. Distinct. Got it. Is that what I want? Yeah, that's probably what I want. Okay. Are these not? What's going on? There's like a bunch of entries that aren't. That's strange. So I get this. That's 274. I do this. Group by player ID. Okay, so this is player ID. There's 56 players. Oh, I see. That's. Oh, nope, that's not it. I want to do summarize. Group by summarize. Silly me. Okay. And I don't think I'm gonna need that anymore. Okay, 49. That was gonna be. Okay, sorry, big mistake on my part. I'm sure many of you were just yelling at me the entire time as this video was going. Oh man. Okay, well, this across trick is really nice though. Okay, so I now have everything I want, but I haven't answered the question yet because I want the best players by OPS, so I need to do a sort. Okay. And OPS. Okay. So the best player is this person, Lou Badro, I think is how it's pronounced. He's a Hall of Famer. That's pretty cool. Okay, so school, University of Illinois Urbana-Champaign. That's us. Hall of Fame, that's pretty cool. World Series winner, MVP. Very, very cool. Here he is. Here's his OPS, 795. What do we have? Always happens, doesn't it? Eesh. 795 is the top one. Awesome. Okay. Cool. So it looks like everything worked. Okay, so great. We have the best University of Illinois player. This person is in the so this is like essentially the highest career honor that you can get in baseball, is to be elected into the Hall of Fame, and this person did it. So one of our alumni is forever memorialized in this baseball Hall of Fame. I do work on comparing players across eras and study this wins above replacement statistic. I hate to throw some cold water on our celebration of our very famous and accomplished alumni, Mr. Lou, how do I say this name? Boudreaux, or we can use one of his nicknames, Old Shufflefoot. Okay, I hate to throw cold water on Old Shufflefoot, but this person amassed a lot of their value in very early eras of baseball by relative standpoint. And most of these seasons are during the World War II depleted league. So essentially a lot of Major League Baseball players served in the war, just drained the talent pool out, and that this person just didn't serve, I guess. A lot of people served, this person didn't, and that's, they're sort of like their best seasons. This would be one of the most depleted years. I guess this year was actually before some of the effort. I think some people had left. So he was good. But leading the league with 10.4 WARs a lot, and very unlikely that he would have done that without the war. Okay. So anyways, still a good player. And, this analysis doesn't do any corrections for error adjustment. So it's very, very simple, but that's okay. Okay. Is this the thing that we want? I think it is. Where's that thing I commented out? Illini MLB batters. Okay. Wow, I really kind of just ran into this. I need to go to Stat385. And I need to give this a name, don't I? Illini MLB batters. This is usually the first thing I like to do. Not my best work in being organized. Okay, Stat35. Save it. Okay, now let's go to our handy dandy auto grader. Illini MLB batters, is that what it was called? Okay. Yeah. I hope I can keep all that stuff around. Oof. Yikes. I'm gonna go fix. See, even I make mistakes too. How embarrassing on something that I studied. But you know what this is? You can see it right here. I used average, and it's the correct name is BA. If I go back to Baseball Reference, let's go back to Old Shuttlefoot's page. Shufflefoot. Yeah, BA. Shoot. Some people use AVG for average, and I've used it in the past, obviously. So, okay, great. So it says current targets. So was that the... Okay. Average BA. Okay, I just want to make sure. That looks like hopefully the only error that I've made. Let's try it again. Sorry if it jittered there. Okay. What happened? Okay, good. So Did I fix the column name? Good. Okay, sorry. All right, so good demonstration in live coding. Coding is difficult, as we can see here, but we ended up getting what we want. So, okay, so we have now found the best player in University of Illinois history in the majors. Okay, if you made it to the end of the video, thank you. And you can see following the steps that I did. And this is the end of the video, but I will talk a little bit more about sort of the work that I have done. So if you're not interested in baseball, just great job, you made it. I'm just gonna talk a little bit longer. Okay, so I have this project that I've worked on with my graduate students. First of all, I'll go to my webpage. So David Dalpiez, who has helped develop this class, is part of the my research group here. And so I've worked on this project with my graduate student, Shen Yan. Where's Shen? Here. And then Adrian Burgos Jr., who's a history professor, on comparing baseball players across eras. Now, our work is, we're very happy and excited and confident in our work, but still undergoing the peer review process. So we've submitted a revision to an academic journal. So these results are slightly out of date, but nonetheless, we have like a career ranking for people by an era-adjusted version of wins above replacement, where it basically works by comparing how well people did against their competition, their direct peers, while factoring in the size of the MLB eligible population or the talent pool. So basically, to do really well, you have to be better than the people you're playing against at your time, and the talent pool has to be large. And of course, there's people who are really, really, really far above their competition, but the talent pool is really restricted. That's like, the classic example being Babe Ruth. So on this version, if I type in Shufflefoot here, it should go to his page. Did the website timeout? Okay, and so we saw his wins above replacement at roughly 63.5. Our thing gives him 36.7. Now, the new version is a lot more favorable, but basically the B-WAR that the wins above replacement that he amassed over his career, he would be lower by our era adjusted standards for the reasons that I talked about, because he played during World War II in a segregated American League. The American League was slow to integrate, and World War II basically drained the competition. So he gets a slight bonus because there's fewer teams. So there's like an expansion effect, which our model indirectly accounts for. So he does get a bonus for that, but net, the talent pool being worse, we see his statistics take a bit of a hit. And I should say here that this number 63.2 differs from this number 63.5 because wins above replacement is something that baseballreference.com is constantly playing around with and changing as they sort of figure out better ways to compute this statistic. So our thing is downstream from wins above replacement. So we have to do a lot of work to stay up to date. I'm not baseballreference.com. I am Shen Yan and Adrian Burgos, and so we're not a company, so it'll take us a bit to get all the updated results, but we were waiting back on our peer review paper. So anyways, but this is something that feel free to use it in your own, if you want to argue with somebody about which players are better all time, we have this for Baseball Reference and Fangraphs wins above replacement. If we go back to we'll just go to Bonds. These are all era adjusted statistics for batting average on base. These numbers will change, and hopefully soon once we get the new version, but Barry Bonds is sort of like the best player. If you don't like PEDs, then Willie Mays is the best player. It's not Babe Ruth. If you like this wins above replacement thing as far as its ability to capture value. So this is sort of some of the work that I do. But if I go to the actual work of this method, it is definitely much more mathematical statistics than it is just looking at baseball stuff. So me and my graduate student worked on actually constructing these statistical rules to compare players across eras. And once we have everything figured out, then we can apply it to the baseball data. So I do really mean that baseball is an example that motivated strong statistical thinking. This model that we developed did not exist before we came around and worked on it, and it would not exist if there wasn't baseball, something that I'm interested in and have thought about for a long time. So, so baseball is very powerful as a motivator for ideas and statistical practice. So even if we're not necessarily interested in baseball, there are lots of lessons that arise from it, or sports, or just maybe anything that you would be interested in that isn't statistics could hopefully maybe motivate statistical thinking and new statistical ideas and concepts. I had friends in grad school who liked fashion, and I think that through their like of fashion, we're able to motivate statistical ideas. So it could be anything. So if you like statistics and you like other things, use the other things to help you like statistics more, and use statistics to help you like those other things more. All right, now it's the true end of the video, I guess. Thank you for sticking around if you did. And I'll leave it on this page so you can see the code. And take care. See you next time. All right, bye.